Okay, so today we'll see just basic switching understanding. So I think you guys know already. So first to switching. So switching bandre. So switching is the process of forwarding data packets so between two devices. So ನಮಗೆ let's say ನಮ್ಮ ಡೇಟಾ ಫಾರ್ವರ್ಡ್ ಆಗಬೇಕಂದ್ರೆ ಸೊ ನಾವು ಸ್ವಿಚಸ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಲೆಟ್ಸ್ ಸೇ ನಮ್ಮ ಹತ್ರ ಮಲ್ಟಿಪಲ್ ಡಿವೈಸಸ್ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು ಒಂದು ಸ್ವಿಚಸ್ಗೆ. ಓಕೆ, ಸೊ ಅಂಥ ಟೈಮಲ್ಲಿ ನಾವು ಬೇಸಿಕಲಿ ಸ್ವಿಚಸ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲ ಇವನ್ ಲೆಸೆ ನಮ್ಮದು ಒಂದು ಆಫೀಸಲ್ಲಿ ಇಲ್ಲ ಒಂದು ರೂಮಲ್ಲಿ ದೇರ್ ಆರ್ ಮಲ್ಟಿಪಲ್ ಡಿವೈಸಸ್. ಓಕೆ, ಸೊ ನಾವು ಡೇಟಾ ಶೇರ್ ಮಾಡಬೇಕು. ಸೊ ಅಂಥ ಕೇಸಸಲ್ಲಿ ನಮಗೆ ಸ್ವಿಚಸ್ ಬೇಕು. ಸೊ ನಾಟ್ ಓನ್ಲಿ ಸಿಂಗಲ್ ಸ್ವಿಚಸ್. ಲೆಟ್ಸ್ ಸೇ ನಮ್ಮ ಹತ್ರ ಫಸ್ಟ್ ಫ್ಲೋರಲ್ಲಿ ಒಂದು ಡಿವೈಸಸ್ ಇದಾವೆ, ಸೊ ಸೆಕೆಂಡ್ ಫ್ಲೋರಲ್ಲಿ ಒಂದು ಡಿವೈಸಸ್ ಇದಾವೆ. ಸೊ ಇನ್ ಕೇಸು ಅದನ್ನು ನಾವು ಕಮ್ಯುನಿಕೇಷನ್ ಮಾಡಬೇಕಂದ್ರೆ ಲೆಟ್ಸ್ ಏನಾದರೂ ಪ್ಯಾಕೆಟ್ ಸೆಂಡ್ ಮಾಡಬೇಕು ಅಂದರೆ ಸೆಂಡ್ ರಿಸೀವ್ ಮಾಡಬೇಕಂದ್ರೆ ನಮಗೆ ಸ್ವಿಚ್ ಬೇಕು. ಸೊ ಬಿಟ್ವೀನ್ ನಾವು ಸ್ವಿಚ್ ಯೂಸ್ ಮಾಡಿಬಿಟ್ಟು ಕೇಬಲ್ನ ಕನೆಕ್ಟಿವಿಟಿ ಮಾಡಿಕೊಂಡು ಸೊ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಮಾಡ್ಕೋಬಹುದು. ಸೊ ದಟ್ ಈಸ್ ದ ರೀಸನ್ ಬೇಸಿಕಲಿ ವಿ ಯೂಸ್ ಸ್ವಿಚಿಂಗ್. So basically forwarding data packet between the network devices. Okay. Then switches are a network devices. So already we know that. Okay. Connect multiple devices together. So already I explained this. Okay. Then so here we have why this is happening. Okay. So here we have layer 2 switches and layer 3 switches. So in my previous classes already I explained those, but let's go through it. Okay. Layer 3 switches operate on data link layer. Okay, so data link layer. So of the OSI model and uses MAC address to forwarding a data. Okay. So idu layer 2 andre namdu MAC base mele forward ಮಾಡುತ್ತೆ. So let's say if I want to send okay, so if I want to send some data, so based on MAC address it will send the data on layer 2. Okay, so this layer 2 switch, so ಇದಕ್ಕೆ ಏನಂದ್ರೆ ಸೊ ಡೆಸ್ಟಿನೇಷನ್ದು ಇನ್ ಕೇಸ್ ನಾವು ಐ ಪಿ ಕೊಟ್ಟರೆ ಸೊ ಅದು ಐ ಪಿ ಥ್ರೂ ಡೇಟಾನ ಫಾರ್ವರ್ಡ್ ಮಾಡಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ಡೆಸ್ಟಿನೇಷನ್ ಮ್ಯಾಕ್ ಅಡ್ರೆಸ್ ಬೇಕೇ ಬೇಕು. ಸೊ ಇನ್ ಕೇಸ್ ನಾವು ಐ ಪಿ ಕೊಟ್ಟರೆ ಎಸ್ ಐ ಪಿ ಹಿಂಗೆ ಮಾಡ್ತೀವಲ್ವಾ, ಸೊ ಅಂಥ ಟೈಮಲ್ಲಿ ಅದು ಜಸ್ಟ್ ಒಂದು ಬ್ರಾಡ್ಕಾಸ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಡೆಸ್ಟಿನೇಷನ್ ಮ್ಯಾಕು ನಮ್ಮದು ಬ್ರಾಡ್ಕಾಸ್ಟ್ ಅಡ್ರೆಸ್ ಇರುತ್ತೆ. ಸೊ ಓಕೆ, ಸೊ ಆಲ್ರೆಡಿ ನಾನು ಡಯಾಗ್ರಾಮ್ ಹಾಕಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ ಲಾಸ್ಟ್ ಟೈಮಲ್ಲಿ. ಸೊ ಯಾವ ಥರ ಆಪ್ ಜನರೇಟ್ ಆಗುತ್ತೆ, ಸೊ ಯಾವ ಥರ ಡೆಸ್ಟಿನೇಷನ್ಗೆ ರೀಚ್ ಆಗುತ್ತೆ, ಸೊ ಯಾವ ಥರ ಮ್ಯಾಕ್ ಕಲೆಕ್ಟ್ ಮಾಡುತ್ತೆ ಅಂತ. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ಹೌ ಪ್ರೊಸೆಸ್ ವರ್ಕ್ ಆನ್ ಲೇಯರ್ 2 ಸ್ವಿಚಸ್. ಓಕೆ, ಸೊ ಬೇಸ್ಡ್ ಆನ್ ಮ್ಯಾಕ್ ಅಡ್ರೆಸ್ ಡೇಟಾನ ಫಾರ್ವರ್ಡ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಸೊ ಬಟ್ ಲೇಯರ್ 3 ಸ್ವಿಚಸ್ ಏನು ಮಾಡುತ್ತೆ ಅಂದರೆ ಬೇಸ್ಡ್ ಆನ್ ಐ ಪಿ ಅಡ್ರೆಸ್ ಡೇಟಾನ ಫಾರ್ವರ್ಡ್ ಮಾಡುತ್ತೆ. ಸೊ ಹಿಯರ್ ವಿ ಕ್ಯಾನ್ ಸಿ ಯೂಸಸ್ ಐ ಪಿ ಅಡ್ರೆಸ್ ಟು ಫಾರ್ವರ್ಡ್ ಡೇಟಾ ಪ್ಯಾಕೆಟ್. ಸೊ ಇದಕ್ಕೆ ನಮ್ಗೆ ಏನಂದರೆ ಸೊ ಲೆಸ್ಸೆ ಡೆಸ್ಟಿನೇಷನ್ ಮ್ಯಾಕ್ ಬೇಕೇ ಬೇಕಂತ ಏನಿಲ್ಲ. ಸೊ ನಾವು ಜಸ್ಟ್ ಐ ಪಿ ಕೊಟ್ಟರೆ ಸೊ ಅದು ಡೈರೆಕ್ಟಾಗಿ ರೌಟಿಂಗ್ ಟೇಬಲ್ ನೋಡಿಬಿಟ್ಟು ಡೇಟಾನ ರೌಟ್ ಮಾಡಿ ಫಾರ್ವರ್ಡ್ ಮಾಡುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ಹೌ ದ ಲೇಯರ್ 2 ಆ್ಯಂಡ್ ಲೇಯರ್ 3 switches works. Okay, not only switches, layer 3 routers also comes. Okay, but layer 2 there will be only switches. Okay, so here we can say layer 3 switches, right? So the look wise we can see switches and L2 switches and L3 switches similar, correct? And by default if we buy switch it will come as L2 only. Okay, there will be no L3. That switch is having features but there will be no L3 enabled. Okay, so if I take example, so 9300 switches. Okay, 9300 switch. So catalyst 9300, we can say catalyst 9300 switch. Okay, so it will look like, let me go through the image. Okay, so catalyst 9300 series switches. This is we can see catalyst 9300. Okay, so this is a single chassis switch. You can see here full image. Let me open that full image. So is there any image? Where is that image? Yeah, so here we can see the images. Okay, so these all are like single chassis images. Okay, so single chassis images we can see, or single chassis switches. So this, if we buy this switch, by default this will be layer 2. Okay, so but this is having the features, so we can utilize this switch as a L3. So if we want to utilize this switch as a L3, so in that case we have to run this command. So to support routing, so we will run this command IP routing. Okay. So even in that switch, so the interface will be by default L2. Okay. So we cannot assign the IP address. So you guys already seen. So when we want to assign the IP address in this interface level, so we do one command. Okay. We run one command, that is no switch port. That means we are making that interface as a L3 basically. Okay. So this is how the L3 features enable in the switches. So that time we can say this is L3 switch. Okay. But by default, just remember by default switch will be act as a L2 only. Okay. But so if I given just example 9300, okay, there are other switches also, but those switches doesn't have L3 support features. Okay. Or we can say L3 features. So in that case, if you try to run this command, right, IP routing, it will not take. So it will show invalid command because that doesn't have that features. Okay, that you have to remember, and you can Google it and you can check whether this switch supports L3 or not. Okay, L3 features or not. So that you will get it from the Google. Okay, so or you can visit the Cisco site and you can see if it is switchco. If it is other model, let's say Arista is there, let's say Huawei is there, let's say other switches also there. Okay, so if you want to have a look about the switches, you can visit the site, better option, and you can have a look whether it is support or not. Okay, so this is the basically L2 and L3 switches. Okay, is it clear or have any doubt?
Yeah.
You should have doubts here actually, because I'm saying switch will have worked as L3, correct?
Okay.
Then why we need routers? We can use switch itself, right? You guys should have this doubt.
For router, why we need router means
Yes.
the routing capacity in the router,
Mm-hmm.
the IP functional thing will be inbuilt. We
Okay.
don't have to make
Anyway,
any.
anyway we are enabling here, right? Then it will work, right? So similar, right?
So it will take like the
Mm-hmm.
all other functions together.
What other
All
functions?
other functions means to transfer the data and to take the like if we are making the L3,
Mm-hmm.
it will go for IP routing and route table also needs to be configured and that it has to be managed that also. So
No.
it will be like taking heavy for this. If
No.
we are keeping the okay.
See here, just we are running IP routing. That's it, extra command we are running. Other than nothing, right? So similar way we do configuration in the router also and even in the switch also. Nothing different.
Okay.
Other all
So
features are
here,
there in the switches also.
yeah, in switches we can take it the interfaces for like we can't take it any other interfaces for like particular taking the servers like
Mhm.
connecting the server and data center connectivity.
No, we can
So
use,
that
right?
we can use. Okay.
See, even switches have the RJ45. Even switches
Mm.
have like 20 gig support ports. That is SAP port. You will see. We have
Mm.
QSAP ports. Lot of
Mm.
options are there in the switches also. Then why we need routers here?
Okay, that's good.
Yes,
Yeah.
that's the questions always should come
Okay.
when we discuss this L3 concept.
Yeah.
See, because routers have more capabilities,
Yeah.
not feature wise, capabilities wise. So if you see like the this one, the CPU level, all the the RAM utilization level. So in
Yeah.
that case, like hard coded some features are there, right? So
Mm-hmm.
that routers having more. So in that case, router can handle more routing information, more route. So in a lakh route, router can handle, but switch doesn't have that much capability. So if we run, let's say in lakh, so switch will get hung because that doesn't have that much capability to handle the routing. switch is having the L3 features we can run, but minimal routing we can run. Okay, so if we run BGP like between other countries, if we say, so that switch cannot handle that much routing table. So if we run 2 or 3 routers, right? So there will be a like a maximum 10 or 15 routes. Okay. So but if we have like multiple routing, so let's say in lakh, so that switch cannot handle that. So that is the reason basically we are using a router, or else other all features can support L3 switch also. Okay. So this is the main thing. So here we can see I have mentioned the key difference here. So here routing capabilities. See, routers have more advanced routing capabilities than L3 switches. So the L3 switch doesn't have that much. Okay. Even the packet forwarding, we can see L3 switch use ASIC for packet forwarding, while router use software-based routing engine. That means this is all hard coded in the we can say router motherboard and switch motherboard. Okay, so these are the features we can see. These are all hard coded, but routing all features we can utilize, like normal software level features we can utilize in the switch also. No issues. So we can configure VPN tunnel, whatever it is, all the features we can utilize. Even the scalability we can see here. L3 switches are designed for large scale environment, while router are better suited for small case, more complex environment. Okay. See, L3 we can use in large scale environment, but where there is a complex environment, so that only I said, right? So we'll use OSPF, we'll use BGP. So in that BGP, we'll use different let's say eBGP, different AS number. So in even OSPF, we'll use different areas. So in that case, there will be complexity, correct? So in that case, we use routers. The switch cannot handle that much. That is the reason. The cost wise, generally routers are more expensive. So L3 is like normal. So when we have like a normal environment or normal complexity environment, we can use switch. Okay, so small episodes we can say. So let's say I just want to open an office in India. That's it. So let's say 1 floor or 1,000 employees. So I can manage with L3 itself, L3 switch itself. No need router, because I'm not doing much routing in that, right? So there will be single office. So I can buy the internet and I can just explore everything. That's it. Okay, so this is the reason we use routers in a environment or corporate. Okay, so here just I mentioned the when to use each. Okay, so that's it. So this is the basic just switching and routers, switches and routers. Okay, then we'll move forward to VLAN concept. Okay, so VLAN, you guys know why we are using VLAN. Okay, so can anyone tell why VLAN is required?
To make a logical dividation.
Okay, so why we need logical dividation? Not required, right? Any specific reason?
The VLAN maintains the network stability, and it will be maintained like there will be no collapse in the network, and the network stability will be good if we use VLAN. Why? Because so without VLAN, the data packets are simply broadcast to the each and every devices and each and every switches. So if we make a VLAN, the particular VLAN can contact the particular VLAN. Like if we make a wherever, like we can set the setup rules to access each VLAN if they want. So it will be helpful for network stability and maintain the network stability.
Okay, so all right, that's true actually. So basically simple. So VLAN for dividation, so we can see multiple virtual network we can create. That's true. Then main thing is what you explained, right? So we can like avoid a broadcasting. So because if we connect switch, right, so it will always broadcast, right? So let's say first, when there is a first entry, it will broadcast the traffic. So we can avoid that broadcast in a network. So let's say if I say I configured VLAN 10, VLAN 20, VLAN 30, right? So VLAN 10 PC can generate a ARP request. So that will broadcast to within a VLAN 10. Okay, so let's say I'm having 12 port. So 4 port belongs to VLAN 10. That means 4 PCs are connected to 4 port. That is belongs to 10. And other ports are belongs to, let's say, 20. So in that case, if PC1 that is belongs to VLAN 10, that will generate a ARP request, then that ARP request will goes to the switch, and that switch will understand which all our ports are belongs to VLAN 10. It will forward it to only that particular interfaces.
Yes.
So there we can avoid that broadcast, right?
Correct.
Yeah. So that is the reason, specific reason. This is the specific reason we can say we are using a VLAN. Okay. So and other features that we can use, like when we have different VLAN, we can set up rules. So let's say we can configure ACL for all the VLANs, and we can divide that. We can divide the traffic. Okay. So that we can utilize. Okay. So this is the basically VLAN we use for. Okay. So then VLAN. So already we know the limitation, right? So VLAN IDs are limited to 0 to 4096. So that means the total count will be 4094. Okay, which can be constant in large network. Is it correct or how? The total count will be 4096. Is it correct?
This is only for one switch. Like what? No, so
No,
this is only for one VLAN.
I'm talking about VLAN ID limitation. So what is the limitation? How much VLANs we can utilize? Is this correct?
Yes, yes, correct.
But I heard 0 to 4096, right? Then it should
96.
be. Then why it is 94 here? The total.
So one will be going for management, and one more like
VLAN 0 and VLAN 4095 reserved VLAN, bro.
No. So reason VLAN. So that also we are calculating, right? Why we are leaving that reserve VLAN? That is reserved is fine. That is not the perfect answer. See, basically, so even reserve VLAN also, anyone can, like other person can use, right? Who is reserved that. So for scientific purpose or somewhere it is reserved, right? They are utilizing, right? But we are not able to utilize. So that means that is also count, right?
yes.
Correct. So here the concept is why here 2 minus, because of 0 and 1, because 1 is by default all the switches will have. Correct. That is, we call it as management or native VLAN, whatever it is. Okay. So that is the reason. So even in interview also they will ask same question. Okay. So because I heard in many interviews. Okay. So they will ask me like what is the count of VLAN? So I'll say like 0 to 496. Then they will again ask what is the count. So if I say total 4096, then they will again re-question it. So how? So then if I say 0 and 1 I am utilizing, then they will say where you are using 0. Okay, so like that questions will come. So in that case you have to properly explain. So 0 we are not utilizing, correct? Then 1 by default switch will be having, correct? So that we are not taking the count, but remaining 4094 VLAN we can utilize. So even if you want more explanation, then you can say there are some like reserved VLAN, so we can exclude that, and other VLANs we can utilize. So even I don't think so, only reserved VLANs are by default VLAN, so that we can see in the switches 1001, 1002, 1003 and 4 and 5, I guess. So if I'm not wrong, okay, we'll see in the switches. Okay, so
I got one question here. So this 4094 is only for entire network?
Yes.
Okay.
So if you want more than this VLAN, then there is one more concept. what is that? In data center we are using, right? So I forgot that name. One second, let me Google it. So I forgot the name actually. I think VLAN, I guess. Let me try
Correct.
VLAN. Yes. So like that
VLAN,
only.
VLAN.
Correct. Yes. So that gives you in a like some count is there. So where is that limitation we can see here?
Actually, they
So
are
in a,
using this as in the only data center.
in the
not
data
in
center, yes. Even normal corporate we are not using that. Only in a data center we are using that. What is the limitation? It is not giving. Where is that? So in a LAC we can use that, I guess. Yeah, if I'm not wrong. In a LAC we can use. Usable limitation or capacity. So underlay hardware. So it is not giving proper capacity of VLAN. What is saying? Yes, even in 16 million logical networks we can use. Yes, not even lakh, in a
They,
million.
like, in the data center, if they provide like data like space to the one company, means they can assign one VLAN for them, right?
Yes, exactly. So even normal. So let's say if I have a company, right? So in that company there will be a data center, right? Specific data center. So there will be multiple servers.
Yes.
So in that case we are using those VLAN into that servers for that particular servers. Okay. So if you have huge data center, then you can utilize this. Or else like normal data center, we can use normal VLANs itself. No need to go with this VLAN. Okay, so yeah, this is the one. Then in the VLAN, there will be a inter VLAN. Okay. So already you guys know inter VLAN, or we call it as SVI, or we call it as L3 VLAN. Okay, so there are three terms we use in the corporate. So basically, everyone will use L3 VLAN like that. Okay, so they will use that term. No one will use SVI or inter VLAN. Okay, some places they will use SVI, or else like normal communication will use L3 VLAN. Okay, so yeah, so SVI is a basically normal. Okay, switch virtual interface, or what we call as. Okay, so we are creating like a normal virtual interface. If we create VLAN, that will be just VLAN. Okay, so that will not make as an interface. So if we want virtual interface, then we are assigning IP address to that VLAN. Then it will act as a interface. That means that is the virtual interface basically. So that is the term basically SVI. Okay. Okay, so here what I mentioned is it's a virtual interface on a layer 3 switch that allows the switch to route traffic between different VLAN. So similar. So let's say if you have different VLAN in the same switch, right? So then the both VLAN, the different VLAN, let's say VLAN 10 and VLAN 10 will be not communicate with each other because that is having different network, different subnet.
Yes.
So there is no proper gateway to communicate with each other. Okay, so because VLAN 10 is having different gateway and VLAN 20 is having different gateway. So in that case, to communicate with a different network, we need a route, right? So that this SVI will provide the route to communicate with each other. So that is the reason we call it as switch to route traffic between different VLAN. So that means the different VLAN can communicate with each other. So this is the basically. Then, so here we can see virtual interface. So SVI virtual interface, no physical one. Okay, so this will be virtual interface. Okay, then associated with VLAN. Each SVI is associated with a specific VLAN. Okay, then layer 3 interface. So similar. Okay, allowing switch to perform a routing functions. Basically, when we make L3 interface, right? So that particular virtual interface, then it will perform routing functions. By default, it will perform. Okay, we no need to configure any routing or something. Okay, by default, it will come like perform. So when we just when we have to assign the IP address, that's it. Okay. Then routing. SVI allows the switch to route traffic between the different VLANs. Similar. So that SVI only have the features to perform the routing. So it will route the traffic between the different VLANs. So this is basically a VLAN. Then we'll see this practically, but before going to this one practical things, we'll understand VTP also. Okay, so we'll understand this VTP and we'll configure both in a lab. Okay, VLAN and VTP, so that it will be helpful. Okay, so here we'll see VTP. So you guys know already what is VTP and why we use that. No, right? Any idea or how?
Can you come again?
So VTP, why VTP is needed? So do you guys have any idea?
Why we need VTP?
VTP, yes.
Means
Is
there
it?
will be 3 types of VTP.
Yeah.
There are 3 types of mode. One is transparent, one is client, and one is server. It has act as a server. When we create VLANs in the server mode, the client mode can take automatically from server mode. In the
Okay,
transparent,
that okay. So I already
how
mentioned
does
there.
it?
But why we need VTP? Is it necessary to configure or how?
To establish the VLANs automatically to the each and every access switches. Like if we don't configure the VTP, and we have to go and configure each and every switches, all the VLANs.
Okay, so
It will take take the VLANs automatically to it will be established the all the VTP which is created in the server mode. So that is the reason we can we are using VTP. It helps.
okay, so let's say if I not configured VTP, what will happen? Okay, so let's say I have a switch here. Okay, so then I have one more switch here. Okay, so then I have one more switch here. Okay, so then one more switch, then one more switch is connected here, then one more switch is connected here, then one more switch is connected here. Okay, so right now just I have the switches, just I done the connectivity here. Okay, just I done the connectivity. So I'll okay, so here what will happen? Okay, so I'm not configuring any VTP here, just I'll create VLAN 10. So what will happen here? So how the process will work or what?
That particular VLAN will be staying there in the same switch. It won't go to the any other switches. If we want this VLAN should we go to the other switches, we have to go particular and physically, and we have to configure all switches.
Okay. If it is like that, then my question is, so by default this switch will have which mode?
The server mode.
Server mode. So then other?
That will be there in the server mode itself.
Server mode. That means what this server mode is saying?
It will be established.
We can simple. We can create a VLAN. We can receive the VLAN. We can edit whatever it is. Okay, server mode have all the features.
Server mode can receive the VLAN.
Yes, server mode can receive the VLANs. Server mode can create the VLAN, edit whatever it is. Okay. All have all server. Okay, correct, right? All features. So then this will be server. This will be server. This will be server. This will be server. So if I create VLAN 10, it will go everywhere, right?
Yes.
Correct?
Yes.
So in this case, okay, so we'll go through the theory first and we'll understand why we need this. Okay. Yeah. So VTP, so we know, okay, so VTP is a protocol that allows core switches to communicate with each other about the VLAN configuration. Okay, so when, let's say, it is enabled to automatic propagation of VLAN information across the network, making it easier to manage and configure VLANs. Okay, so let's say if I have 100 VLANs, so in that case, if I configured 100 VLAN in the switch, let's say count, I'm saying, okay, 100 count. So 100 VLANs, if I configured in server mode or normal switch, okay, directly if I configured in normal switch, it will propagate to all other connected switches, but the connectivity should be trunk. Okay, so
Yes.
it should be allowed trunk. So in that case, all other switches will be receive the VLANs because all switches will be having by default server mode. So that is what this definition is saying. Okay.
Okay.
Then similar here we can see VTP carries VLAN information to all switches in VTP domain. So this is also one matter, okay. So when we configure domain, right? So it will look for domain. So based on the domain, it will propagate the VLAN information, okay. Or we can say VTP advertise can be sent over 802.1q. So when VTP sends the VLAN information, right? So it will use this one. That means trunk only, right? Encapsulation 8021Q. This is the protocol. Or else we can see ILS. But nowadays we are using this one only. 8021Q. With help of this, it will advertise the information and it will send the information to other switches. So based on that, they will receive the information and they will update in that switches. Okay, so this is basically switch works. So here we have server mode. Already we know server mode what do. Okay, so VTP server mode maintains the VLAN configuration database. Okay, so let's say if I create VLAN, it will create there itself. Okay, so it will send the update to other switches also. Okay, then we can edit the VLAN. That means we can delete the VLAN. Okay, so if we don't want, we can delete the VLAN, or we can, let's say, we can edit it, whatever it is. Okay, we can do that changes. So there is a one more mode, that is the client mode. Okay, so in the client mode, what features we have? Only receive the information, whatever the server mode is sending, right, or advertising, that client will receive and update in that switch, particular client switch. Okay, so that feature client is having. So here we cannot create a VLAN or we cannot edit, whatever it is, we cannot do anything. So this mode will do just receive the information and it will update in that particular switch. Okay. Then transparent mode. So this transparent mode, what this transparent do is, so when we configure transparent mode, so we can create the VLAN, but it will not send the information to other connected switches or other neighbors, whatever it is. Okay, so it will keep in that particular transparent mode switch itself. Even this will not receive the information from other server switches. Okay, so let me connect this. RDP is disconnect. Now reconnect it. What happened to this? The host is unreachable. Give a minute, guys. Let me have a look. Why this disconnected? Network got disconnected from the remote system. It is connected. What is that? CMD, what is the IP address for this? IP config. Zero dot 5 itself. Then why it is not pinging? Ping 68.0.5. Okay, so I think that this one is enabled. Okay, yeah, now looks good. Okay, so all right, loading. So that's right. Then okay, so all right. So we understood the transparent mode, similar, okay? It will not receive the VLAN information from the server, okay? So it will be like transparent, it will be standalone, we can say, okay? So this is how this 3 mode works, okay? So in that case, now the questions comes, why we need this? So as we know, if we configured, let's say if we connect simple network switches, by default, if we create VLAN 10, it will propagate to all other switches, correct? In that case, why we need? So the reason is, so let's say, I have a VLAN, let's say I have one server mode here. So, and remaining I'll keep as a client mode. Okay. So in that case, if I create VLAN in the server mode, so this server mode will send the information to all other connected clients.
It is freezed.
Yeah.
Can't,
Sorry.
can you explain now again?
Yeah. So let's say when we have a network topology, so we will keep one as a server mode, correct? The reason. So if I create VLAN, so all other client switches can have the VLAN information. So because server mode will send the VLAN information.
Yes.
So let's say if I use by default switches, right? So by default will have server mode. All the switches will have server mode. So let's say I'll create VLAN 10 here. Okay. So it will propagate to other server switches.
Yes.
So by mistakenly someone will create VLAN here in the server, right? So other switches also having server features.
Yes.
So then again, this will propagate to our main server switch. So in that case, it will be problem. So we cannot like stay consistency. That will be the problem. Okay.
Yeah.
So that is the reason we are using. So in that, if you want to Google it, right? So if we, it will give proper information. Okay. If we use server mode in multiple switches, VTP server mode in multiple switches, what will be the drawback? Okay, so it will give. So using multiple switches in VTP server mode is a highly risky and generally not recommended because it creates a single point of failure and can lead to catastrophic network wide LAN loss. Okay, so if a server get a higher configuration revision number, accidentally deleting all VLAN from the entire domain. See, so there will be one revision number. So when we create VLAN, right? So it will generate one revision number. So I'll show in that configuration. Okay. So if that happens, then there is a chances to delete the VLAN. So if the VLAN is deleted, so that particular users which all are connected to that particular VLAN, they will lose the connectivity. So that is the one risk what we can see here. So that is the reason we are following this concept. So we are keeping one as a server and other as a client. Okay. So in some cases, we may need only few VLANs. Okay. So let's say from, let me change the color here. From this switch, only servers are connected. Okay. Normal servers are connected, let's say. So normal servers are connected. Okay. So normal servers are connected. And this switch need only VLAN, let's say 100. Okay. So because from this switch only servers are connected. So if we create VLAN here 100, okay. So then this server switch will what will do? It will propagate VLAN 100 also plus VLAN 10 also. Correct? But this switch doesn't need this VLAN 10. Okay, so in that case, to avoid this, we can make this as a transparent. Okay, and instead of creating VLAN here, we can create here. Okay, so we can avoid this one, because if we have multiple VLAN in this switch, it will take some space, right? It will utilize some CPU, it will utilize some memory. So we can avoid that. So this switch will perform well then. So in that case, we are using a transparent. Okay. So when we have users, so let's say here also users connected, here also users connected, so here also users connected, and this user will use, let's say VLAN 10, VLAN 20, VLAN 30. Here also say VLAN 10, 20, 30. Here also 10, 20, 30. So in that case, we can keep this as the client. This will be client. This also will be client. This also will be client. This also will be client, and this will be as a server, act as a server. So if I create a VLAN 10, 20, 30, it will propagate to all other this client switches. This client switches. So in this scenario, we are using a VTP. Okay. Or else we can connect the switches and by default it will take the VLANs. But there is a risk. That is the reason we are configuring VTP in the network. Okay. So all right. Then I think trunk and access port I kept somewhere below. Okay, so let's cover that also, and we'll move to the lab. Okay, so at one time we can cover all three topics. So where is somewhere here I kept. Okay, let me go to that. Drag little bigger. Okay, so I hope it's visible, right?
Yes.
Okay, so already we know what is trunk, correct? So trunk can carry multiple VLAN traffic, so which is tagged VLAN traffic. So here we can see the definition. A trunk port is an Ethernet interface that carries traffic for multiple VLANs simultaneously between switches, or between a switches and routers or firewall that understand VLAN tags. So based on VLAN tags. So why I am saying here the tag is, so in this scenario, okay, let me remove this. Okay. So let's say from this switches, there are 3 PCs are connected. PCs are connected. Okay. So this PC belongs to VLAN 10. This PC belongs to VLAN 20. Then this is VLAN 30. So all this traffic will come to this switch. So this switch will have traffic VLAN 10, 20 and 30, correct? So when this switch wants to send to the neighbor switch or up towards uplink, we can say, it will choose trunk port, correct? This is the uplink, that will choose trunk port. Yeah, so in that case, this will bundle this traffic and it will send from the trunk port. So in that case, this will receive the traffic, correct? This switch will confuse now. So which traffic is belongs to VLAN 10, which traffic belongs to VLAN 20, which traffic is belongs to VLAN 30. So there will be conjunction, correct? So in that case, the trunk what features gives, it will add the VLAN number. So that particular packet. So let's say one packet is coming from here, one packet is coming from here, one packet is coming from here. So here the trunk port, what it will do, it will add the tag. So let's say one packet is belongs to VLAN 10. That means this is our tag. Okay, similar, the second packet which is coming from VLAN 20, right? That will be 20. That means in that packet header, right, it will add the tag. So in that case, this switch can understand, okay, this packet 1 is belongs to VLAN 10, then the second packet which is coming that belongs to VLAN 20. So in this case, the trunk will work. Okay, so that is the reason we are saying it is carrying multiple VLAN traffic in a single port, or we can say single physical cable. So, but it is adding a tag number to avoid the confusion. Okay, so this is the basically VLAN trunking. Okay, so then so here I've just mentioned how it works. Okay, so when a switch sends a frame on a trunk link, it tags it with a VLAN ID using 802.1q encapsulation. So this is the protocol, encapsulation protocol. It is used to tag a VLAN number. Okay, so then that VLAN's tag allows the receiving switch to know which VLAN the frame belongs to. Okay, sorry, so I mentioned that packet. So because in the switching level, or we can say in L2 level, the frame will become, okay, there will be no packet. So when we comes to routing, right, let's say L3 network layer, at that time we call it as packet. Okay, so in the switching level or L2 level, so data link layer, we call it as packet, because the switch, when the traffic received from the physical link, right, it will convert to the frame, not in packet. So by mistakenly I use that packet word instead of packet. We can use the frame word. Okay. So this is the one. Then the VLAN tag is 4 byte inserted into the Ethernet frame. Okay. So the VLAN tag, so it will have 4 byte. We can say, okay, so this is the 4 byte tag. So not in MB, it is in byte. Then native VLAN traffic. So by default, VLAN 1 is our native VLAN, right? Is not tagged. So that native VLAN traffic will be not tagged. So in that case, if we see here, when there is a 3 frames, it will add the tag. So let's say one more PC is connected here, and that is belongs to VLAN 1. VLAN 1. By default port will be VLAN 1, right? So then this traffic will not, let's say this frame, right, VLAN 1 frame, there will be no tag. Okay, so there will be no tag for this VLAN 1. There will be no tag. If VLAN 1 traffic is coming here, right, so it will not add the tag, directly it will send to the switch. So switch will understand, okay, so non-tag traffic is coming, right, that traffic belongs to VLAN 1. Directly it will understand this switch. Okay, so this is how it is work. So that's the reason I mentioned here native VLAN traffic. Okay, so we can change the native VLAN also. Okay, so there is one command, so we can change that native VLAN. So this is the basic understanding of native VLAN. Even in the single line I explained. Okay, so why we called as native VLAN? So this is the reason. So normal VLAN will use the tagging concept, but here native VLAN will not add the tag, so there is not tag. Okay. Then trunk configuration. So here we can see how do we do trunk configuration. Okay. So here you can see one more command, that is trunk allowed VLAN. Okay. So we'll see that command in the practical. Okay. Why we do this allowed VLAN. Okay. We'll see in the practical. So let's quickly, we'll see the access port. Okay. So already we know access port will carry only single VLAN traffic. Okay. So here there is no tag concept because it is single VLAN, right? So no need to add a tag and all. So directly it will carry that particular VLAN traffic. Okay. So it will send to the PC. So basically if you want to see the diagram here, where is that? So let's say this is the switch. So this is PC10. Then it will directly send to the this switch. So no need to add, because this switch will understand whatever traffic coming from this interface, that is belongs to 10. So no need to add a tag and all. Okay. So then sending towards trunk, it will add the tag and it will send it towards next switch. Okay. So this is how the access port works, and we can see the access port configuration. Okay. So by default, the Ethernet port will be access. Okay. So no need to run this command, but as a practice, many people run this command. Okay. Or else we can directly statically assign that particular VLAN with the help of this command, switch port access VLAN 10. Okay. Okay, we'll see in the lab now. Okay, we'll configure one topology and we'll see. Okay, so similar topology I have created for BTP. We'll use that and we'll see. So you guys will get the proper understanding. So here we can say this is how I prepared the topology. It's a simple topology. Okay. So I made one transparent switch above, then server switch, then client switch. Okay. So here I'm covering all the three modes. Okay. So in the same topology, we'll use VLAN concept also. We'll create the VLAN and we'll see it. Okay. We'll go to the lab here. So it is saying small. Little bit more, or little bit more, or little bit more. Okay, so quickly we'll create a topology. Again, this remote is making slowness. I don't know why this is. If it is this much slowness, then how I can work. Let me check the settings. Something is wrong. Yeah, I could see the packet loss. The latency is good, but why this packet loss? Okay, so here we'll add a switch. Okay, CILIOL. So this is EVNG. Okay, so I'm using EVNG because we'll get more. We can run more command. Okay, so in packet tracer will not get the commands which we use in live network. So that is the reason I am using here. Then let's say we'll make this switch as L3. Okay, so this is my L3 switch. So we can say this will be act as a server. Okay, server mode basically. Then we'll take two switches. So now, okay, that is not taken the name. Okay, let me edit it. There are some packet. Okay, server mode. Taken, yes. Then this one will be like a transparent mode. Transparent mode. Okay, we'll keep like this. We'll keep like this, or else we can make it this L2 itself. No need to make it L3. We'll change it to L2. Okay. So, okay. So let me add 2 more switches. IOL. Why this switch is making slowness, man? Okay, so this will be client. Fine. I didn't change this one. Okay, let me change the logo. Switch. Save. Then one more switch. Edit. Change the logo. Switch. Okay. So now let's do the connectivity here. 0 to 0. Then there are some packet loss. 0 0. Okay, so we'll connect one more here. Okay. So now we'll turn on this. Start selected. Okay, so why this is not got selected? Oh no, why this is not starting, man? Okay, shit. I made a mistake here. So I didn't selected this one. Okay, the switch version, I can say, the bin file. Wrongly I selected that bin file. That is the reason it was not powering on. Let me select this L2. Okay, see the name is L2, but it supports L3 as well. Okay, it supports L3. So now we'll open this in Secure-CRT. Secure-CRT. Okay, so keep it here. Okay, like this. Then let me open this also, switch 6. Then let me open this also. Then let me open this also. Okay, so open it, fine. Now server mode. So we'll do the configuration, enable. So host to, sorry, config terminal, host name. Already we discussed how we do this host name. Okay, so let's say this is our server mode switch, right? Server mode switch. Okay, so I can say like a VTP server mode. So you guys can VTP server mode. Okay, so easily we can see the name and we can understand which is what. Okay, so here what I will do is, so I will configure first trunk interface. Okay, so all this interface will be belongs to trunk, right? So let me configure this one, interface range. So what is the range? Ethernet 0/0 -2. Okay, so fine. So I'm using range command. Okay, so now switch port mode is trunk. Okay, so if you want to say here, once again, do show trunk, do show interface trunk. Okay, so right now we can say, here we can see, so Ethernet 0, 1 and 2 already is in desirable mode. Okay, so that means it is in already in trunking mode. So by default switch will have auto desirable mode. Okay, switch port mode trunk whatever we configured, right? So in that mode we have this option as well. Okay, switch port mode desirable, or one more mode is there, that is auto. Okay, so we can see here switch port mode question mark. So here we have one option is trunk. Okay, but here it is not showing. Okay, so dynamic desirable it will take, or how desirable. Okay, so this is not supporting that command, or switch port mode. Okay, so anyway this command is not working here. Okay, we'll see in other model or something. Okay, but by default the switch will have the desirable mode. Okay, that is what we called as DTP. Okay, so if you are not configuring this switch port mode trunk also, right, it will take the trunking capacity. Okay, so by default it is in trunking mode status we can see here, but still for standardized purpose we will configure as a trunk. Okay, switch port mode trunk, let's say it will take. So it is asking for enable the encapsulation. Okay, the some switch will have by default enable this encapsulation, some switches will not have this encapsulation enabled. So here I will enable it, switch port trunk encapsulation .1q. Okay, so then I will enable this switch port mode trunk. Okay, so now we'll see do show. So same command, right? Do show run, do show interface trunk. So now we can see here the mode is now on, that means it is in trunk mode now. Okay, previously it was in desirable, so by default it was in desirable. So now we enable. Okay, so what happened to this? Meeting is ended, I guess. Choose team. Okay, thank you for choosing team. Extend your meeting. Okay, so let me create another one. Teams. Okay, calendar. Edit. Join with same link. Okay. Screen. Okay, so it is visible, right? So where is Kumar? Screen is visible, right?
visible ಆಗಿದೆ.
Okay, then all right. ಸೊ ಇಂಗ್ಲಿಷ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ಅಲ್ಲ? ಆಲ್ ರೈಟ್ ರೈಟ್?
ಏನಿಲ್ಲ,
ಯಾಕಂದ್ರೆ ನಮಗೂ ಸ್ವಲ್ಪ ಪ್ರಾಕ್ಟೀಸ್ ಆಗುತ್ತೆ, ಇದು ಯೂಸ್ಫುಲ್ ಆಗುತ್ತೆ ಆ್ಯಕ್ಚುಲಿ. ಸೊ ಅದಕ್ಕೆ ನಾನೇ ಇಂಗ್ಲೀಷ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಯಾಕಂದರೆ ನಿಮ್ಮ ಜೊತೆ ನಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ರೆ ಇನ್ನು ನಾನು ಎಲ್ಲಾದರೂ ಕಮ್ಯುನಿಕೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ ನನಗೂ ಯೂಸ್ಫುಲ್, ಕರೆಕ್ಟಾ? ಸೊ ಇವನ್ ನಿಮಗೂ ಹೆಲ್ಪ್ಫುಲ್ ಆಗುತ್ತೆ. ಸೊ ಲಿಸನ್ ಮಾಡಿ ಮಾಡಿ. ಸೊ okay, so he's saying he will join next class. I some emergency. Okay, carry on. Okay, we'll continue. Yeah, so as we can see, once we enable the trunk, it will, the mode will show as a on now. Okay, so and other information we can see here, the VLAN, what it's showing, the VLANs allowed on trunk is 1 to 4094. So that means, so all the trunk ports, so 0, 1, 2, now right now can carry all this VLAN information or all this VLAN traffic, we can say. 124,094. But right now, the switches doesn't have all those VLAN, right? So once we configure, then it will carry the information. Okay, so this is how we can see. And we can see here VLAN allowed and active in management domain. So right now, only one VLAN is active in this domain. So that means, so if we create other VLANs, then it will show other VLANs also in active state. Okay. And here we can see some other information, VLAN in spanning tree forwarding state and not pruned. So right now there is no VLAN, so that is the reason it is showing none. Okay, so only the VLAN 1 is the by default VLAN right now. Okay, so once we configured, we'll see this output again and we'll understand so what all are changes is there. Okay, so now enter undo. Okay, so the trunk configuration is done here. So whatever we needed, that is done. So we'll do configuration in other switches. Okay, so the trunk configuration quickly we'll do same concept. Okay, so config terminal, let's say host name, then switch 6 we can say, that is our, sorry, we can say not required switch it, we can say client, VTP client. Okay, VTP client mode we can say. Client mode. Okay, then what else? So interface is Ethernet 0/0. Interface Ethernet 0/0 is switch port. The space is not taken. Okay, switch port trunk encapsulation .1q. Then switch port mode is trunk. That's it. Then done. Right. Then similar here. Enable config terminal host name. Host name, what is that? Client, sorry, VTP client mode. Done. Then interface Ethernet 0/0. Then switch port encapsulation. Switch port switch port trunk encapsulation .1q. Switch port mode. Then enter, then right, done. Then similar will configure this one also. Config terminal. Then host name is VTP transparent mode. Okay, then what it's showing, node name is using Cisco ISS. Okay, host name VTP transparent is not a legal LAT node name. Okay, using a Cisco. Okay, fine. So this is giving just warning. Okay, no issues. So we can keep that transparent mode. Okay, so then here interface Ethernet 0/0 it should be trunk. Switch port trunk encapsulation .1q switch port mode then trunk. Okay, so end right. Okay, so here we'll see show. Okay, show VTP status we'll see. So now we are going to configure VTP. Okay, so we'll see the status first. So transparent mode, we can see the VTP version right now. So VTP version capabilities we can see 1 to 3. Then VTP version running we can see right now it is running in version 1. So domain name is not configured. Even VTP pruning is not configured. We'll discuss this last. Okay, so pruning. Then VTP traps also not configured. Then we can see the device ID, the MAC address of the device. Okay, this one we can see. Then other feature, other option we can see here. The operating mode right now it is in server. By default it will be in server. The maximum VLAN supported locally we can see here 1005 VLANs. Maximum VLAN supported locally. Okay. Then what we can see, the number of existing VLAN we can see 5 VLANs are there. Then configuration revision number is right now 0. Okay. So here what we have to see, we have to see this one, this changes and this changes is very important. Okay. So this one will be based on our configuration, what we configure, what we do the configuration. Okay. So Just remember these two things. Okay, so if I check in other switches also, the status will be similar. Okay. Show VTP, sorry, double time show. Okay, VTP status. So it will be similar. Okay, so right now this is same, nothing changes. So all switches are having similar thing now. So we'll start from server mode. Okay, we'll do the configuration, VTP configuration, config terminal, VTP. First we'll change the version. Okay, VTP version will make it 2. Okay, then we'll do VTP mode. We'll configure VTP mode as a server. So already in server, no need to configure. It is showing already in server. Okay, no need to configure. Then let's say VTP domain. We'll configure domain. So we'll configure test.com. Okay. So domain is our test.com. So it is giving some logs, we can say. Okay. So even here we can see the changing VTP domain name from null to test. Previously it was null. There was no domain name. So now I have configured test.com. So that is what we can see here. Even in the log we can see that is one. Okay. So VTP domain name changed to test.com. So then what we need, we'll configure password also. Okay. So we'll understand the password things also. So now VTP password will keep 1 2 3 4. Okay. So simple password 1 2 3 4. So setting VTP password to 1 2 3. So this much is good enough. Then end. Then we can see show VTP status now. Okay. So right now there is a changes. Okay, these all are we configured, we know it already, we know it. Okay, so VTP version 2 we configured, test.com configured, even in the password also we configured. Okay, so here is the things we can see when we enable this VTP configuration, right? So we observe this one VTP, the configuration revision number we can see the 1. Okay, so the revision number 1 it is showing. Okay, so just observe this. Okay, we'll see in the second switch. Okay, we'll configure here in the client switch. Okay, so config terminal. Now VTP similar thing will configure. VTP version will configure 2 and VTP version 2. What is showing? Version is already in 2. Okay, so just a minute, let me go here. Okay, so in the client, this client, okay, show VTP status. Okay, so let's see this one. So when I configured this all things in server mode, right? So we see this one, the version is changed, domain is changed, even password also I guess set. Show VTP password. VTP password not configured. But so here what we can learn is when there is all switches in server mode, okay, and we are configuring VTP in server mode. Okay, that means single switch. So because right now all switches are in server mode, right? So we are taking one switch and we are configuring VTP. So what we configured? We configured VTP version, we configured VTP domain. Okay, so even we configured VTP password. In this case, what this server mode is doing, it is sending the information to other server switches because these all switches are in server, right? So it is sending the update to all other switches. So what all are update it is sending? Only the version and domain. It is not sending that password. Okay. So that is the reason in switch 7, this one switch, right? So 7 switch is there. So in that switch, we can see the domain name and the version, but password is not there. It is showing password is not showing, not configured. Okay, so password we have to configure manually. So in this case, so if I configure VLAN in this switch, right? So server mode switch. Okay, so that VLAN information will be not send to the other server switches, because those switches doesn't have that password, correct? So it will not match. So in that case, those switches will not receive the VLAN. So let's try, because only server mode switch we have configured properly, correct? So here we didn't configure that password, or we didn't configure anything. Okay. Okay, even transparent mode switch also will receive that, because we didn't configure it as a transparent. So if we see show VTP status, right? Show VTP status. So even this is also received already. Okay. So even we didn't configure transparent. Okay. So it is received. So now, well, I'll configure VLAN. Okay. So VLAN, let's say configure terminal, then VLAN, let's say 10. Okay. So name I will give, let's say data. Okay. So there is some logs. What it's showing? Let's see the logs. What the log is showing? So VTP user notification, VTP protocol user notification, MD5 digest checksum mismatch on receipt of equal revision summary on trunk Ethernet 0/0. What this switch is saying? So I am trying to send this information, but there is no password matching in recipient. That means this switch, our client switches, which is neighbor. So there that password is not there. That means the password is not matching. That is the reason the logs we can see here. That means this switch will not receive that VLAN information. So if I check here, even here also we can see some log, similar log, but let's see is there in a VLAN. Okay. To show VLAN brief. Okay, so here we can see VLAN is not there, but in the server mode switch we have the VLAN. Do show VLAN brief. So VLAN, sorry, here also it's not configured. Why? So okay, let me reconfigure and let's try. But should be exit. Okay, then VLAN 10. Okay, then exit. Okay, do show VLAN brief. Okay, so now it is configured here, but in other switches, let's see whether it is there or not. It should not be received. Yes, it is not receiving. That means that password is not matching, correct? So first time it is given the warning, or we can say the log. So in the second time, I don't see the VLAN. Okay, so right now there is no VLAN and the revision number is saying 1. Okay, so the revision number is saying 1 in the client switches. We can see in the client switches the revision number is 1. Do show VTP status. So here we can see revision number 1 right now. Okay, so this revision number, why it came? Because of this configuration, the domain name and the version. That is the reason one revision number is counted here. Okay, so but in the server switch, so right now it should be 2 revision number. Okay, so as per my understanding it should be 2 revision number. Let's see whether it is having 2 revision number. Yes. Okay, because when we configured VLAN 10, right, so revision number increase. Now it is 1. Okay, so just remember, when we are configuring this VLAN, it is increasing, right? Now we'll configure this client, this one, and we'll see. We'll configure this one, password, because already we have the VTP information. Okay, we'll just configure the VTP password. So VTP password is 1234. Setting device password to 1234. Okay, fine. So now show VLAN, do show VLAN brief. Okay, so till now it is not taking the VLAN information, Okay, so even if I try here also, right, it will not take the VLAN information. So because server switch, first time it's tried to send the information, then it's found there is no password matching. That is the reason it is not sent. That means second time it is not sending. Repeatedly it's not sending. That is the reason this is not receiving now. So here also we'll configure that VTP password and we'll see VTP password is 1234. Okay, so now password is matching, but there is no, that server switch is not sending the VLAN information. Do show VLAN brief. What we will do now, so we will shut this interface and we'll see. Okay, so from this switch we'll shut uplink and we'll unshut it. Okay, so we'll unshut it. So that is interface Ethernet 0/0. I'll shut it. Okay, so that means now the communication is not happening between these switches. Now the interface is shut down. So let me unshut it. No shut. Okay, now let's see, is there any VTP information sent here? Okay, so I don't think so. It will send the VTP information, but still let's try. Okay, yeah, it's sent. That means when we do shut and no shut, right? So this switch will understand. Okay, so there is some switch is connected again. That means it will send the VLAN information to that switch. What this switch is understanding, the server switch, is something new switch is connected. So in that case, I have to send the information, correct? So it will try to send the information. If the password domain is matched, then this client switch, this below switch, will receive the VLAN database. Okay, so if we do here also, right, similar thing will happen. So let me do here. Interface Ethernet 0/0, then shut, then no shut. Okay, so now the VLAN information should be here. Do show VLAN information. Yes, now we have the VLAN information here. So I hope this is clear before going to this one. So one more thing I'll show you. Show VTP status, I'll show you. So the revision number will change, right? Because here VLAN is received. Show VTP status. Okay. Do show VTP status. Because one VLAN is added, that means revision number is changed. And even the existing VLAN also changed. Previously it was 5. That means 0 to 1015. That means let me show you. Show VLAN brief here. Sorry. Do show VLAN brief. Okay. So previously there was a 5 VLANs, right? VLAN 1, 2, this one 1003, 1004, then 1005. So that is the reason previously it was count was 5. So that's the reason I said just remember the count. Okay. Previously it was 5. Okay. So now one more VLAN is added. 10. That is the reason the count is 6 now. Okay. And the revision number, when we configure VTP domain and domain name and version, the revision count will be increased by 1. When we add VLAN, the revision count will be increased based on VLAN. So let's say if I configure VLAN 20, the revision number should be increased and the VLAN existing VLAN should be increased. Okay. Let's say VLAN 20. Let's say wise, sorry, name should be wise. Let me give name wise. Okay, now it should be increased. Okay, so VLAN brief. Okay, so now VLAN is added. Let me check the VTP status now. Show VTP status. So here we can see existing VLANs are increased and the revision number also increased. So if I see in the client also, it will be similar. Show VLAN brief, 20 is added now. Then VTP status, if I want to show VTP status, do show VTP status, see, here also increase. Okay. So this is clear, right? So VTP server mode and client. Is it clear?
Bro.
Okay, so here what you learn now. Okay, what all things you learn. So if I give scenario now, let's say I have server switch, okay, server mode switch, and I have one client switch. Okay, so in the server mode switch, I have created VLAN 10 and 20, but this switch is not receiving the VLAN. The client switch is not receiving. So what all are the configuration you will check, or how you do the troubleshooting? What all step you will take?
Check version
Mm-hmm.
and domain
Mm-hmm.
password.
Okay. Anything else? This is the troubleshooting concept. Okay. Anything else you will check? See, everything is okay. So let's say everything is okay. This VTP configuration is fine. Version is fine. Version is matching. Domain is matching. So then password also matching. But still, the switch is not receiving the information. What you will check? Any other thing you will check? Give some work to your mind now. Otherwise, it will not work. You have to think. Think quickly. Show VTP status. Right now, only revision number is 1. Okay. So any idea or not?
And so this is client switch.
Client switch ಅಲ್ಲಿ ಬರ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ ಏನು ಚೆಕ್ ಮಾಡ್ತೀಯಾ ಬೇರೆ? VTP configuration is all right. But ಬೇರೆ ಏನು ಚೆಕ್ ಮಾಡ್ತೀಯಾ? So what I will do is now. So what we can check is, if let's say interface is down, the VLAN will be, the client switch will receive the VLAN. Do you think so? Uplink is down, or downlink from the core switch, downlink is down. Do you think that switch will receive the VLAN? Or let's say even though properly trunk is not configured, do you think it will receive the VLAN information? Yes or no? True, right? So when we comes to troubleshooting, everything we have to check, not only VTP configuration. Okay, so these all are basic thing. If the interface is down, let's say some went to error disable, the interface is went to error disable. In that case, you will never check, right? So you will think interface is up. How? So in that case, you have to verify all those things. So first thing is enable. So if you are confident, then you are going to the VTP, check the VTP status or VTP configuration, then you check the show interface status first. Okay, so because here you will see if it is connected, if it is not connected, then it will show not connected, or it is error disable. Okay, there are 3 possibilities we can see here in the status, so you can understand what is the issue. Okay. So based on that, you can, if it is physically everything is looks fine, then you can check the VTP. Okay, we can troubleshoot. So all those version, domain and password. Okay, then fine. So this server and client is fine now. So now, okay, we'll see the transparent mode switch, right? So what I will do is config terminal. So I have added one more switch that we will make it as a transparent. Okay, so interface, then let me shut down this. So interface 3, so I just shut it down, interface 3, because if I enable this, right, once I powered on this switch, so the information will go here, the domain and version information will go here. VLAN will not go, but information will go here. That is the reason I just shut down that information. That means, so I don't want to make the same configuration here, because I want to keep a transparent mode, right? So we'll do freshly here. So that is the reason. Okay, so before going to this new switch, we'll see in the transparent mode switch. As per our plan, we do this one transparent, right? So if you see VTP status, right now the revision number is 1 and the VLANs are 5. By default, the VLANs are 5. Okay, so then domain is taken, password we have to set. Okay, before that setting the password, we'll make it VTP mode as a this one. Okay, so even here we didn't change this mode, right? So we have to change the mode. Okay, so we cannot keep that server mode. So if we keep, there is a risk as we read in the theory. Okay, so let's change this one also. So VTP mode is client. Okay, that's it, nothing else, just VTP mode should be client, that's it. Here also similar, then VTP mode should be client, or else there is a risk. That is the reason we are changing this to client. Okay, so or else you can keep it a server also, but there is a risk. Okay, we'll come to the transparent mode. Okay, we'll change the VTP mode first. Configure terminal. So you got it, why I am changing VTP mode first? Have you understood or how? Or else I'll explain why I'm changing VTP mode transparent first. Then I'll set the VTP password. Okay, VTP password is 1234. Okay, now all fine. Show VTP status. So I just configured. All right. Okay, so I'll explain here. So here you can see, if I can configure directly VTP password, right? So because this switch is by default server mode, if I configure this password, this will take the information from server mode switch, right? This switch, main switch. Then we can see the existing VLAN will be increased, then revision member will be increased. That is the reason what I done is I just configure VTP mode transparent. So in this case, the mode will be different from the server switch, server mode switch. Okay, there will be the mismatch. So in that case, the VLAN information will not propagate in this transparent mode switch. So that is the reason why I configure this transparent mode switch. Sorry, transparent mode. Okay. After that, I configure the VTP password. Then here we can see the revision number is 0 now, because this is a standalone switch. It isn't transparent. So revision number will be directly 0 here. Okay. So before that, we have seen this revision number, right? When this switch was server mode. So when we configured as a transparent, the revision member went to 0 now. Okay, the VLANs are 5. So let's see VLAN, we'll configure the VLAN and we'll see how the revision number and VLAN, existing VLAN will increase. Okay, so let's say VLAN 50 I'll configure here. Okay, then 50 is good enough. Okay, then do show VLAN brief. Let's verify whether it is created or not. Okay, whether it is created, then do show VTP status. Okay, so now you can see here in the transparent sheet, only this existing VLANs are increasing, not revision number. Okay, so this is what we can see in the like transparent mode difference between the client and transparent mode, we can say. Okay, so revision number is not increasing. Okay, so if let me create one more VLAN 20, then let's see, the VLAN number should be increased, but the revision number is not increasing. Okay, so this is the one difference we can see It will be standalone. Okay. So this VLAN will not propagate in other client switches. If you see here, right, show VTP status, there will be no VLAN. Show VLAN brief. See, only 10, 20 are there. So 50 is not there. Okay. Okay, then this one is finished. Okay, wait a moment. So, ಇಲ್ಲಿ ಏನಾದ್ರೆ doubt or any question? Here also you should have one question, but you are not thinking that way. Are you there? Hello, you are not audible if you are talking.
ಕೇಳಿಸ್ತಿಲ್ವಾ? ಹಲೋ,
ಇವಾಗ ಕೇಳಿಸ್ತಾ ಇದೆ.
ಹೇಳಿ.
ಓಕೆ, ಸೊ ಎನಿ ಡೌಟ್ ಇಲ್ಲಿ ಏನಾದ್ರೆ ಕ್ವಶನ್ ಏನಾದ್ರೆ ಬಂತ? ಆಕ್ಚುಲಿ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಒಂದು ಕ್ವಶನ್ ಇರಲೇಬೇಕು ಇಲ್ಲಿ. ಯಾಕಂದ್ರೆ ವಾಟ್ ಐ ಮೆನ್ಷನ್ಡ್ ಈಸ್, yes, correct, revision number. Why it is not increasing here? Correct. Because see, this switch is not belongs to VTP, or we can say it is not participating with the VTP, right? Because this is transparent. It is not forwarding the information or it is receiving the information. It is keeping itself. So that is the reason the revision number is not increasing. But in other switches, there will be forwarding and there will be receiving. That is the reason the revision number is increasing there. So this is very important in the interviews. Okay, so they will ask like that only. So why the one thing they will ask that similar scenario based questions, what I told you already. Then second thing, they will ask why this revision number is not increasing in transparent mode and increasing in normal mode like server and client. This is the one thing you can explain. Okay. Then one more thing they will ask, this VTP pruning they will ask. Okay, so this one they will ask. So this pruning, okay, so what I mentioned is, let me go here, server mode, right? Okay, so here if you see show interface, let me exit it, do show interface trunk, right? Trunk. So we do see here the pruning concept, whatever we are discussing. This is the pruning concept. Okay, so here in this line we can see right now what it is showing: VLAN in spanning tree forwarding state and not pruned. So let's understand what is pruning. Okay, before going to this, so pruning is concept. Let's say let me take a topology, then we can understand better way best. Where is the rubber? Where is that rubber? Here I think. Oh. Okay. Already 9:20. We cross a lot today. Pen. Okay. So if I say so if I say switch here, one more switch is here, one more switch is here. Okay, so then this is the connectivity, then okay, so this is below, clients are connected, below clients are connected. Okay, so here all are belongs to VLAN 10, no? Okay, VLAN 10, no? So these all are belongs to VLAN 10. Then here belongs to Okay, so all R belongs to VLAN 30. Okay, then here, okay, so all R belongs to VLAN 40. Okay, so now this is trunk, this is also trunk. Okay, so if I have not enabled this pruning, right, so all VLAN will be in not pruned state. That means, so if this PC, this let's say VLAN 10 will generate a ARP request, correct? So it will broadcast to everyone. That means it will broadcast to this switcher also. It will broadcast here also, that particular R packet. Okay, it will broadcast all the switches and all the connected interfaces or connected users, or we can say the PCs. Okay, so to avoid that, because VLAN 10 belongs to only this switch, correct? So in that case, this one has to broadcast only between these clients or these PCs. No need to broadcast here, right? Because VLAN information, whatever we want, we will get from this switch itself. So here VLAN 10 is not there itself. So in that case, no need to broadcast here. No need to broadcast. Okay, so no need to broadcast here, no need to broadcast here. So if we enable this pruning, right, this pruning concept, then it will not broadcast this side. It will not broadcast this side. Okay, so this VLAN 10 will not broadcast this side, VLAN 20, VLAN 30 will not broadcast this side, VLAN 40 will not broadcast this side. So within the switch it will be there. So if let's say here also VLAN 10 we have, and we have enabled pruning, here also we have enabled, here also we have enabled. So in that case, now what will happen? So this will broadcast here also. Let me take a green color. So now this R will come here also. That means this is now broadcasting. Incoming. Okay, so this is now broadcasting. So now here it will not broadcast. So this side will block. This side will block because here VLAN 10 is not there. So in this switch VLAN 10 is not there. So that is the reason it will not broadcast this side. Only between these switches it will broadcast. But if I talk about VLAN 30 information, right, it will not broadcast to switch 1, this switch, because VLAN 30 is not there here. So that means between this it will be there. So let me show you the configuration, how we do the configuration VLAN pruning. Okay, so this is the server switch. Okay, so right now we have VLAN, this one also, here also we have. So what I can do is transparent mode. Okay, so let's say in the transparent mode we have only 50, right? So and then show VLAN, show interface. So trunk, let's see here. Okay. VLAN 2050 is there. Okay, there are 2 VLANs because previously it was taken the 20, so 2 VLANs are there. So all are in pruned. Let me configure the pruning. Okay, so VTP pruning, what is that command? Okay, pruning, that's it. So now I enabled pruning. So now we'll see here, show interface trunk, right? Show interface trunk. So now we can see the pruning is, what is that? Okay, so particular interface we can see Ethernet 2 is the 1, 10 and 20. Ethernet 2 is what? This one. Okay, this is pruned. VLAN 1, 10, 20. So Ethernet 0 is only, this is not pruned, this is not pruned. The remaining 2 VLANs are pruned. So that means now Ethernet 0/0 is connected to this switch, client 6 switch, and Ethernet 01 is connected to client 7 switch. So in this case, switch will, if let's say this switch generate a ARP request, okay, this client, so it will send it to server mode switch. This server mode switch will send it to this switch. Okay, directly it will send it to this switch. So that is what here we can see. Okay, so even this will send it to this side also. Okay, so let me do one more thing. So what I can do is I can let me do one thing. If what the topology we need a different type, then only we can say. Okay. Okay, let me take different example. Okay, so here it is pruning. Let me enable the pruning first. So in all the switches, then I will clearly explain. Or else I need to create a different topology and I have to show it. VTP pruning. Okay, then done. Then VTP client 7 also, let's say, enable config terminal, VTP pruning, then end. So even in this one also, VTP config terminal, VTP pruning, then done. Okay, so now show interface. If I do trunk here, so here what we can see now, see these all are not pruned VLANs. Okay, that means if let's say I have connected one PC here, transparent mode, so that PC will be belongs to, let's say 1 or let's say 50. Okay, let's say 50. So this 50 traffic will send it towards this side, this switch. Okay, and that 50 traffic will not broadcast towards these clients, because here what we can see that VLAN 10 is not there, correct? This VLAN 20 already in this switch because of that server mode configuration, so you just ignore this. Okay, so if only this 50 will be pruned, that means this 50 traffic will goes to this server switch and it will net forward to this VLAN 10. Okay, so that is what here we can see. So in this switch also, if we see client switch, show interface trunk. So here we don't see that VLAN 50, correct? So this 10 and 20 is pruned. Okay, 10 and 20 is pruned. So that means once the client is generated ARP request, it will comes to server mode switch and it will send it to 10 and 20 VLAN only. Okay, so it will not send this side because this switch is having only 50 VLAN, right? You just ignore that 20 VLAN because it's taken previously. So before configuring transparent mode. Okay, so it will not take the broadcast traffic, or it will not broadcast the traffic from this port Ethernet 0/2. So that is the reason we can see here. Okay. So this is how this pruning is work. So rarely this pruning concept they will ask. Okay, so you can say in simple way to avoid the broadcast in other switches, those doesn't have that VLAN, so we are using a pruning. Okay, we are enabling a pruning. That is the basically concept. So any doubts here? So we have covered 3 topics today. So any doubts, or else we'll close this one. If you are talking, you are mute.
Hello.
Yes.
Hello, bro.
Yeah, I can able to hear you now. Any doubts or something, or else we'll close. Clear, right? Okay. All right then. Okay, we'll close this.